Hi, everybody. Today we are going to take a look at the kinematic equations. The kinematic equations are a set of equations that are used to help describe the motion of objects. The kinematic equations are going to take a look at 5 different variables or measurements that we use frequently in describing motion. They are displacement of the object, the initial velocity of the object, the final velocity of the object, acceleration, and the time it took an object to move. These 5 principles and concepts are interconnected in 3 distinct equations. The derivation of these equations can be seen in another video I have produced, and I encourage you to understand where they came from. They ultimately are going to come from the basic concepts that we started this course with, that every object has a position, that as that position changes, the object is being displaced. That displacement over time is going to give us the velocity of the object, and that the rate at which that velocity changes is called acceleration. Together, putting those principles into a unified equation, we get what we refer to as the kinematics. The kinematic equations are not numbered in any book as kinematic 1, kinematic 2, kinematic 3. They are not universal like the laws of thermodynamics or Newton's laws. But for the sake of this course, I will refer to the kinematics in the order 1, 2, and 3. So that way, when we are communicating about problems, we can very easily say, let's do kinematic 1, or let's use kinematic 1 here, instead of having to say, let's use the kinematic that looks like, and then rattling off the entire equation. The first kinematic equation, as we will describe it, says that the final velocity of an object is equal to its initial velocity plus its acceleration times its time, the time it takes to move. This is all happening in a single direction of motion, either the x direction or the y direction or the z direction or some skewed direction to the x, y, and z, where we have turned the axes so that it is considered to be one-dimensional. We will use these equations for two-dimensional motion later on in the year, but for right now, let's only think about them in their terms of one-dimensional motion. To do two-dimensional motion, we have to do some modifications and include the equations for both the x and y direction. The second kinematic equation is displacement is equal to the initial velocity times time plus 1/2 the acceleration times the time squared. The third equation is that the final velocity squared is equal to the initial velocity squared plus 2 times the acceleration times the displacement. Together, these equations have the ability to solve for any of the 5 variables on the left-hand side. Any 4 of these will be in one equation. That is that when we take a look at this first equation, there is no displacement. There are 4 of the 5 variables, but there's no displacement in the first equation. In the second equation, there's no mention of final velocity. In the third equation, there's no mention of time. And so you can solve for the variables using the equations that have what you want and also have the ability to plug in 3 pieces of data to get the 4th. Whenever we have an equation and we don't have initial velocity nor acceleration, we need to solve for them first. To solve for the other variables, we generally need to have the initial velocity and the acceleration first. Solve for those values, figure out those values, read and write down those values if they were given, and then once you know those values, you can move on to solve for the other variables. I'm going to give some example problems that I will post behind this. If you have any questions, let me know.